Chapter 10 Circles, Exercise 10.2. Question 1. Recall that two circles are congruent if they have the same radii. Prove that equal chords of congruent circles subtend equal angles at their centers. So this is the this is the theorem. The equal chords of a circle of equal chords of congruent circle subtend equal angles at their center. So let us see how to prove it. So we need two circles, one circle with a center O and another circle with center O dash. Now two equal chords AB and CD and the angle subtended by them at the center. Okay. Now it is given that two congruent circles with equal chord AB and CD. We need to prove angle AOB equal to angle CO dash D. So how to prove? So in triangle AOB and CO dash D, AB equal to CD because it is given that equal chords. Now this OA, OB and O dash C and O dash D, they are radius of the circle. So since the circles are congruent, all the radii are equal. That means OA equal to O dash C. Similarly, OB equal to O dash D. Radii of congruent circles. So the three sides of triangle AOD correspondingly equal to three sides of other triangles. So that means the triangle are congruent by SSS, congruence criterion. So what we can say, angle AOB equal to angle CO dash D. The reason is corresponding part of congruent triangle. So this proved that equal chords subtend equal angles at the center of congruent circles. Question number 2. Prove that if chords of congruent circles subtend equal angles at their centers, then the chords are equal. This is converse of the previous question. The equal chords subtend equal angles at the center that we had proved. But in this, the angles, if two chords subtend equal angles at the center, then the chords will be equal. So the same way we have to prove this. So let us take two congruent circles, one with the center O and other with the center O dash, and two chords AB and CD, and they subtend equal angles at the center. Now what is given? Two congruent circles, then angle AOB equal to angle CO dash D. That means the angle subtended by the chords at the center are equal. That is given. Now what we need to prove here? The chords are equal. That is AB equal to CD we have to prove. So let us take like the previous question, let us consider the triangle AOB and CO dash D. And in that, angle AOB equal to angle CO dash D because it is given. Then we know that AO, BO, CO, DO, OD or OA, OB, OC, OD. These are the radius of the congruent circles. They are equal because the circles are congruent. So OA equal to O dash C and OB equal to O dash D, radii of congruent circles. So here we proved that these triangle are congruent, that is two sides and included angle. That means the triangles are congruent by SAS congruence rule. Two sides are included angle. So that means AB equal to CT by corresponding parts of congruent triangle. Thus we proved if chords of congruent circles subtend equal angles at their centers, then the chords are equal. Now let us move on to exercise 10.3. Question 1. Draw different pairs of circles. How many points does each pair have in common? What is the maximum number of common points? So let us draw some pair of circles. So first pair, two congruent circles. There is no point in common. Now let us draw another pair, one small and one big circle. There are also no points in common. Now let us draw another pair with a one common point. Now another pair with the two common points. That means the maximum number of common points that can have for a pair of circles is 2. Question 2. Suppose you are given a circle, give a construction to find its center. So let us see how we can find the center of a circle. So this is a circle. We need to find the center of the circles. So first we need to mark 3 points A, B, C anywhere on the surface of this circle. Next we need to join the chords AB and BC. Next, we need to construct bisectors of these two chords. So how we will construct bisector? In the compass, take more than half of this length and cut an arc here and here from both the points without changing the measure of the compass, and you will get the meeting points, join them. Now similarly you need to construct the bisector of AB also. So perpendicular bisectors of the two chords, they will meet at a point here. So that meeting point is the center of the circle. Question number 3. If two circles intersect at 2 points, prove that their centers lie on the perpendicular bisector of common chord. So let us see two circles, one with center O and another with center O dash. And they are meeting at 2 point AB, and AB is the common chord and M is the meeting point. Now let us join the radius, and we have to prove AM equal to MB. Then only M will be the midpoint of this chord, and we also need to prove, see, the centers lie on the perpendicular bisector. So we need to prove that angle AMO equal to angle BMO equal to 90 degree. So that other all angle will become 90 degree. So for that, first let us consider AOO dash and BOO dash, these two triangles. In that, OA equal to OB and O dash A equal to O dash B, because they are all radii. Then OO dash equal to OO dash common. So these two triangles are congruent by SSS congruence rule. Now we can say that angle AOO dash equal to angle BOO dash, corresponding part of congruent triangles. Now let us consider triangle AMO and BMO, these two small triangles. In this, OA equal to OB because radius. Then OM equal to OM common. Now angle AOM equal to BOM. This is we already proved here. So these two triangles also become congruent. Triangle AMO congruent to triangle BMO by SAS congruence rule. Now when these two triangles are congruent, we can say that AM is equal to BM, corresponding part of congruent triangles. That means M is the midpoint. Now we can also say that angle AMO equal to angle BMO. Angle AMO is equal to angle BMO. Again, corresponding part of congruent triangles. But when you observe, we can see that angle AMO plus angle BMO is equal to 180. Why? Linear pair. But AMO is equal to BMO. So I can substitute AMO in place of BMO. So AMO plus AMO equal to 180. That is 2 AMO equal to 180. So angle AMO is equal to 180 by 290 and angle BMO also 90. So thus we proved that the centers of these two circles lie on the perpendicular bisector of the common chord. Thank you.